there is a bag where there are 8 red balls and 6 blue balls. First, what's the probability of picking 1 red ball? Well, that's easy, right? The number of favorable cases, we have 8 possible red balls from which to pick a red ball, and then the number of total balls that you can get when you pick one is actually 14 possible cases. So the probability we're looking for is 4/7. Number 2, what's the probability of picking 1 red ball and 1 blue ball? In order to assess the convenience of these 2 methods, we are going to calculate using the 2 methods. This second question. The method 1 is using the approach of one single fraction. So, in the first part of this fraction, the numerator, we need to consider all the favorable cases for the result we want to get. 1 red ball and 1 blue ball. What are all the favorable cases? Let's use counting methods here. We have first 2 possibilities. We can either get a blue and a red ball, or first a red and then a blue ball, right? Any order is possible when picking 2 balls with that result, red and blue. But in how many ways can we get 1 blue ball and then a red ball? Well, we can combine because the 2 balls have to be obtained together. We can use our multiplication principle. The blue ball can be gotten in 6 possible manners, while the red ball can be gotten in 8 possible manners. So the multiplication gives us the total number of ways in which we can obtain a blue first and a red next. Similarly, getting first a red and then a blue ball can be in 8 times 6 ways. So the sum of these 2 cases will be the total number of ways in which we can get a blue and a red ball in any order. What about the denominator? Here we have to consider the total number of outcomes that you have when picking 2 balls randomly out of the bag. For this, we can also use counting methods. If we are getting 2 balls out of 14, so this is, a problem of subgroups. Here we can say the first ball can be any of the 14 balls. After I pick the first, the second can be any of the other 13 that remain in the bag. So you can see that this product and this sum in the numerator, they make the probability. Okay, we have 2 times 6 times 8 in the numerator, in the denominator 14 times 13. We can do some simplification and we get the probability 48 over 91. Let's see if we can get to the same result with the second method. The second method says, okay, step number 1, let's pick a sequence of letters that represents 1 possible outcome. Okay, red and blue. That is our sequence. Next, let's calculate the probability of that chain of results. The probability of having a red-blue first would be, according to what we did here, 4/7. What is the probability of getting next blue ball? Okay, consider that the number of favorable cases for the blue ball is 6. But what is the total number of outcomes when we have already chosen 1 ball from the bag? Actually, in the bag, there is no longer 14 balls. It's just 1 fewer ball. So, there are 13 balls. 6 favorable cases out of 13 possible cases for the blue ball. So here we just see that the result is 24 over 91. Okay, let's proceed to our step number 3. Why? Because here the question doesn't suggest any specific order of the 2 balls. So it might be any possible order. So we need to calculate what is the total number of ways to rearrange this sequence of letters. Well, this is two different letters, so it's just the factorial of 2. And factorial of 2 multiplied by the probability we calculated in the step 2 would be 48 over 91. So that's it. The answer is the same with both methods. But we can see a tendency to have like a bulky calculation in the numerator, okay, if we use method 1. On the contrary, the number of operations we need to do with method 2 is always the same. Let's verify this with the third question. What's the probability of picking 2 red balls and 3 blue balls? Well, here if we do step number 1, that would be checking one sequence of letters that represents a possible result of the 5 balls. So it could be, for example, 2 R's and 3 B's. 2 R's standing for the 2 red balls and 3 B's standing for the 3 blue balls. Okay, and let's just say it's this specific order. So the second step is calculating the probability of that sequence. Based on the principle of multiplication, we calculate the probability of every letter and then multiply them all together. So what's the probability of getting first a red ball? Well, that would be simply 8 favorable cases out of 14. Once a red ball is out of the bag, we have another 7 favorable cases for the second red ball out of a total of 13 balls in the bag. Next is the calculation of the probability of the first blue ball. There are 6 favorable cases out of 12 possible balls because in the back, the balls are being reduced back one by one after you pick one ball because of this without replacement. For the second blue ball, you would have only 5 balls left, 5 blue balls left in the back, and 11 balls left in total in the back. So 5 over 11 is the probability of getting a second blue ball. Likewise, for the third blue ball, we have 4 favorable cases out of 10 possible outcomes. So this product represents the probability of this sequence. It's easy to simplify. Here, 7 goes away with 14. Okay, this 2 goes away with 8. You just get a 4 here. Then you can see, right, 4 and 2, 12. Can simplify, you get 3. 6 times 5, you can simplify with 3 times 10, which is 32. So finally, you get a 4 in the numerator and 13 times 11, which is 143 in the denominator. We proceed to step number 3. Now we need to calculate the number of ways in which this sequence can be rearranged. Why? Because each of these possible arrangements has the same probability 4 over 143. So we need to put together all those probabilities by means of a sum, and that would be the total probability we're looking for. So counting the way in which 5 elements with repetitions can be arranged is using this formula. 5 factorial divided by 2 factorial, because of the repeated r's, there are 2 of them, times 3 factorial, because of the 3 repeated b's. So expand this like 5 times 4 times 3 factorial, cancel the factorials, 5 times 4 divided by 2 equals 10. So now I just multiply 10 times the probability in the second step, and that's 40 over 143. That would be the probability for this question. Trying to do this using the approach of method 1 is quite complex and time-consuming. That's why we recommend method 2 when you need to multiply probabilities or there is a compound event with many multiple events that are repeated, individual events repeating themselves, with different results, forming a compound event.